Okay, grade 12. So yesterday we created this main method that in theory should do the following. We have an array of data. The cat sat on the mat. So it is a 3-slot array with 3 parts of a poem in it. We then ask the user, or we will be asking the user, for the name of the file we're going to save. So we're going to say, hey user, give me the name. We will then save the data to that file. We will then ask the user, hey user, what file do you want to open? In theory, they'll open the exact same file. And then we will call a method that will open that file from the computer system and return it as a string of text, and then we'll output that string to make sure it worked. Okay? So this is kind of the theory behind what we did yesterday. This data will be saved to this file name through a bunch of code that we're going to write that's built also, we didn't show this yesterday, inside of a class. We built a class to take care of this. And it'll save it on our hard drive. And then when we go back the other way, when we open it, the same thing will occur to display it on our computer screen. Okay? So that's the process. But again, I want to stop for 1 second and see if you guys remember this from the other day. When we save this thing, we're going to call it poem. But that's not enough. If I call it poem, what's missing from the name of this file? I'll give you a hint. This is just its middle name. What's missing over here? And what's missing over here? The first and last name, right. The last name of this will be whatever we want it to be. But so you guys are familiar with it, we could put something like .txt because it'll just be a text file. Most files on the computer are actually just text files. They just hide that from you. Like HTML is a great example. An HTML file is also just a text file. They just happen to put .html there so that when you double click it, it doesn't open up in something like Windows Notepad. Instead, it opens up in a web browser. But ultimately, it's just a text file. And then the first name for this file will be our path. Okay? Which will be like C/whatever, like whatever. Okay? So we got to remember that. So now when we get to our code, and we go to our file handler class, and for now, get file name will be very simple. We are going to change that in a couple minutes or tomorrow. But for now, let's give it a first, middle, and last name. So here's what I'm going to propose for now. Let's make a string for the first name, middle and last name, and then one called file name equal to first plus middle plus last. Okay, and then we'll return that. So we're not going to ask the user at this point. We're just going to code it in right now to get this working. We're going to code in a first, middle, and so the middle name we know, it's poem. The last name we know, it's .txt. The first part is the tricky one for you guys because the path where you place this file will depend on everybody's computer. Like right now, I don't think you students are allowed to write a data file to the, for example, the C drive, unless, like Stephen, you're working on your own computer, then that'd be fine, right? That's fine because it's your computer. But I think the network security here at the school might not allow that. So what I might suggest you guys do is just from your desktop, just open up a folder that you know you can put stuff in. Like, for example, you should have a folder with your name on it. And then inside there, maybe you have a folder called My Documents. And you know you can write stuff in here. So I'm going to steal this address from up here. I'm going to highlight it, and I'm going to press Control-C to copy it. Now, obviously, that's for me. Yours will be different. But I'm going to select that and copy it. I'm going to take that to my code and paste it. Okay? Now, notice that when it pasted it, this is a new feature of the new NetBeans, it automatically puts 2 slashes for every slash. Remember, it needs to do that because 1 slash usually means something like a new line character. So 2 slashes is how you actually make a slash. And there's one other thing missing. We need to also put 2 slashes at the very end of this. Okay? So you've got to put 2 slashes right there as well. So really, the name of this file is sjsdfs1.sjsd.lcl/staff/lwalk/documents poem.txt, because I am concatenating all 3 of those pieces together to create the full name of this file. The whole file name is there. Okay? So now when I go to save this, that's what it's going to try to do. It's going to save that whole thing. Now, later in this period or tomorrow, we will actually ask the user for that data. But for now, let's just hard code it in. So if we look back here in main, when it asks the user for a file name right here, it's going to return that name. So that's the name it'll save to. And then later when it tries to open it, it'll just use that name. So that's the name it'll open it with. Okay. So now let's focus on save. Okay? The method called save. We want to save data to a file name. Okay? Here's what we have. Sitting in this thing right now is an array of 3 things. The cat sat on mat. That's being passed, an array of size 3. This is being passed to it, which is this long string that has a bunch of slashes, lwalks, poem.txt. That's being passed. So we have everything we need to save this. We have the entire path, the first, middle, and last name, and we have all the data that we actually want to write into that file. We have everything we need to get going here. So let's do that. Let's get going. In the diagram yesterday, I explained that through saving, we're going to use 2 Java built-in classes, but the entire thing is going to be surrounded in this thing called an error trap. So let's set the trap. We set the trap with what's called a try block. You write the word try, and it's called a block, just like an if block, because it uses curly brackets to build the structure around the try block. So the curly brackets are there. And again, you can put your curly bracket here as well if you want. You don't have to put it up there like I did. Okay? And every try block has a matching catch block, like that. And let's say if we catch an error, let's just do system out, and let's just put error. That's as simple as it can be. But that's not enough. That's not enough for this error trap to work. What you need to tell inside the catch block is what type of error are you catching. Okay? And what we're catching is one of these, IO exception. And you can use Control Spacebar to help with this. And let's just call it error. Okay. Now there's still going to be a bit of an error there. It'll still probably give you a little red line. But what should have also happened is up top in your code, you should now see an import happening up here. An import line should have appeared up here. And I said this yesterday, so you should be able to get this. No prizes for this one. What does IO stand for? Come on. Input, output, right. So it's an input, output error could occur here. Okay, anyone not there? Okay, so now this is all the code that we need inside there. It's inside the try block where we're actually going to put our code at this point. So inside of try, we put all the code we're about to try to execute. Remember, if at any point an error inside the try block happens, and that error is a file error, it won't crash your program. Instead, it'll come down here to the catch statement and continue along. So that error trap is now set. Okay, so inside the try block, we're going to create an object of type file writer. And again, you can use Control Spacebar to help build this. Notice the capital F and the capital W. This is not an object you're going to be building. This will be an object that will be imported automatically, or you might have to use the light bulb to import it into your code. So this is not an object you write. This is an object that some other programmer built for you. Notice it uses the same style I've taught you. Capital letters, lowercase letters, camel casing. So let's give it a name. Let's just call it writer. Equals a new file writer. Now, at that point, you will notice there are 5 constructors for this class. Okay, and again, I'm reviewing classes a little bit with you guys as we're doing this. 5 possible constructors. So in other words, you can't just make a file writer with empty round brackets. You have to pass it one of these 5. Now the first 2 seem to have as a parameter something that you're not familiar with, a file object and a file descriptor object. Well, we don't know what those are. But the third one looks perfect. All it needs is a file name, and we have that. We already have that. It was a parameter of our method. So that's the constructor we're going to use, is the third one, and pass it our file name, which is kind of what I did in the diagram. So we have a file name right here that is now connected to our file writer class. It's actually locked into it through the constructor. But now we need our second object called a print writer. And I know you're thinking the word print is weird. We're not actually doing a print to a printer, but what we're doing is we're affecting a stream, what I talked about yesterday. And we'll call this thing file. We have no other good name for it. Equals new print writer. And what I put in the brackets this time, I'm not going to go through all the constructors with you, is the writer. So what we're having here is, remember, this is the file name that ends in poem.txt. That thing is passed to our writer object, and then our writer object is passed here to our print writer object. From this point forward, all we'll be using is the print writer object called file. That's what we'll be using, and actually, it's pretty simple how to use it. To use the object called file, we just go file.print, and it will actually, just like print or print line, it will output the data, but not to the screen. Not like system.out.println. It's not outputting to the screen. Instead, we've redirected the stream, so it's printing to the file. So if I do this print line, and I pass it a string of data right here, it will write that data into the file. So what we have for data, however, is an array. We have an array of data. So to use the array, we're going to use a for loop and go through data.length. So we use the loop, and then we go file.print, and we go print line. Print line will add a line break, and we print data bracket I. So that will write each piece of the array to the file. Write it, write it, write it. So it doesn't matter how big the array is. It could be 3 lines or 3 indexes, or it could be 3 million. It'll keep writing it to the file. But then we actually have one last line of code here. We have to say file, and this is outside the loop, dot close. This line of code right here, file.close, severs your connection to the file. You'd think that that would happen automatically, but Java likes to keep files open in case you need to do more to it unless you tell it to close the connection. So that line has to be executed to specifically sever the connection to the file. So here again is the code that we've written that will execute a file save. So let's see if it works. I'm just going to run my code. And at this point it runs, but it comes back with a null. That's because we haven't written open yet. Open doesn't do anything. But what's interesting is, if I take a look at that folder that I said I was going to save into, which is this folder right here, there happens to now be in this folder a file called poem. And it appears by Windows to look like a text file. So rather than open it in NetBeans, I'm going to double click it, and look at that. The cat sat on the mat. It actually saved it to our text file, which is exactly what we wanted. Now that you guys can write code that can create files, there's a lot of potential mischievery that you guys could do. Think about it. Writing data to files, using loops, potential virus opportunities and things like that, all kinds of crazy stuff. Okay, should we stop there today, maybe? You think that would be a good place to stop? Or no, why don't we dive into open? Let's see what we can do. Yeah, sorry, Zuhar, which way?
I have like an error where it says static string open.
Oh, yeah, don't worry. We're going to do that right now. Let's do open. It's not that much longer than save, to be honest with you. So let's write open. And believe it or not, it uses most of the same kind of code. Does anyone else need a minute? Okay, let's write open. I had written that line return null. Let's get rid of that. Okay, so open, like save, will have the try-catch block. So you can go ahead and write that, or you can even copy and paste it from the other one. I'm going to copy and paste part of it. Okay, so it starts off the same. Open has the try-catch block. Open as well uses similar objects. It uses a file reader object, and we'll just call it reader equals a new file reader, and you pass it the file name. So far it's looking the same, other than instead of writer it says reader. But it's not, as I said yesterday, called a print writer. Instead it's called a buffered reader. I'll call it file again. Equals a new buffered reader, and there I pass it my reader. Okay, so slight difference on opening. File reader looks similar, but it's this idea of a buffered reader. And again, remember, a buffer is just a waiting line. It's a way to wait. So it's when I'm opening the file that I create this buffer, so that just like when you open videos on YouTube sometimes, especially if you have a really slow internet connection, it might actually tell you buffering video, okay, which means it's reading it in slowly. And that's what we're doing here. We're opening the file, so it's possible that that might be a little too slow for us. So that's why it's created. Because again, I mean, a 3-line poem is not a big deal. A 3 million line poem, that might take a little more time. Okay, any red lights? Any grade 12s? No? All right, we keep pushing forward. So here's the thing. We now can use this file object to do what's called a read. And there's actually several different ways you can read here. Okay? The two that we're going to focus on is read line and just read. Okay? And actually we're just going to focus on read line. Read line, as you can see, returns a string. So it sends back a string of data to you. The reason it's called read line is it reads up to a new line character. So that's the one we're going to use. But we need some variables to make this work. We need a string of text that will start off blank, a blank string of text. We also need a string for our line equal to file.readline. So we'll read in a line of text. But we have no idea how many lines of text are in this data file. It could be 3, it could be 3 million, it could be 0. We have no idea. We need a structure that will continually keep reading until there's no more lines. What coding structure do you know that can do things repeatedly? Right? Now the bigger question, which of the two loops is more appropriate here? That's right, the while loop. Because remember, the while loop is designed for when you don't know when to stop looping. The for loop is designed for a specific number. We have no idea how many lines are in this text file. So that's why the while loop is more appropriate. So we're going to say while line, because we keep reading the line, is not equal to null. Null is how we know when there's no more lines left. If it reads nothing, then we're done. So while it's not a null, our text equals our text plus our line. Plus, we have to add one other thing. We actually have to add the new line character. Believe it or not, read line reads up to the new line character, but it doesn't actually put it into the string. So we have to manually attach a new line to the end of this. So we say text equals text, because we keep filling this text variable up with the line that we just read plus a new line. And then we execute this line. Line equals file.readLine. So we read in the next line. So here it'll read in the next line, go back up to the loop, check to make sure it's not a null. If it's not a null, add it to the text, read in the next line. Go back up. If it gets past the end of the file, in other words, it reads a null, it'll leave the loop. And then finally, we have to say file.close. We have to close it again. And because this method is a return method, we return our text. Now, there's still one other potential error. Because this is a return method, you have to add one last line at the end of this that just says return null. That has to be outside of the error trap. So you have one last line at the very end where we return null. Now, if all is right in the universe, and I know I went fairly quickly, so tomorrow I'll do a quick review of this. You should be able to see your poem output on the screen if all is right in the universe. And it seems like such a simple thing that this 3-line poem is appearing on your screen. But what's going on here is way more complex. You saved the poem to a file, then you opened it back up before you displayed it on the screen. So here's the finality of this. Hopefully the cat sat on the mat before we leave today, and the cat sat on the mat. So that is an excellent piece of code that is working there. And we'll stop there for today. And yes, Zuhar, if you need, I'll put some more code up on the screen for you.